German tank commanders saw something impossible that morning. German Panther and Tiger tanks boasted superior armor, more powerful guns, and better engineering than American Shermans. Yet in battle after battle, from the bocage of Normandy to the forests of the Ardennes, American tank units achieved kill ratios that defied the technical specifications. At Aracourt in September 1944, the 4th Armoured Division faced German panzer brigades equipped with Panthers that outclassed Shermans in virtually every measurable category. When the smoke cleared 3 weeks later, Americans had destroyed 281 German armoured vehicles while losing just 41 of their own. 7 Germans died for every American, an outcome that should have been impossible. The answer wasn't visible on any battlefield. It couldn't be measured in millimeters of armor or caliber of shells. The decisive weapon lived in the electromagnetic spectrum carried by radio waves that German forces barely understood they were fighting against. This is the story of how 181 pounds of radio equipment proved more lethal than any gun. The invisible battlefield. Modern military theorists speak of network-centric warfare as a 21st century innovation. They're wrong by 6 decades. The first battlefield network came online in 1942, built not from fiber optics or satellites, but from vacuum tubes and copper wire installed in every American Sherman tank rolling off Detroit assembly lines. While German engineers obsessed over sloped armor and long-barreled guns, American engineers at Motorola were solving a different problem. How do you make 50,000 tanks think as one? The answer transformed warfare more profoundly than any weapon system before or since. German intelligence files from 1944 contain disturbing reports from frontline commanders. American tank units demonstrated coordination that Wehrmacht doctrine claimed required visual contact. Scattered formations executed complex maneuvers across terrain that made sight lines impossible. Artillery support arrived with supernatural speed. Every Sherman seemed aware of every other Sherman's position. German analysts attributed this to superior training. They were catastrophically wrong. Chicago's secret weapon before Pearl Harbor, Galvin Manufacturing Corporation, made car radios. The company, soon renamed Motorola, seemed an unlikely candidate to revolutionize armored warfare. But on July 22, 1941, the US Army made a decision that would determine the war's outcome. They standardized 3 radio models for all medium tanks: the SCR-508, SCR-528, and SCR-538. The contract went to Motorola. 2 engineers made it possible. Daniel E. Noble understood how Edwin Armstrong's frequency modulation technology could work in combat vehicles. Henryk Magnuski, the principal RF engineer, solved the brutal challenge of making sensitive electronics survive the hell inside a moving tank. Vibration, temperature extremes, electrical interference from engines and weapons. Their creation weighed 181 pounds and required 2,748 individual components assembled to tolerances that strained American manufacturing capability. The BC604 transmitter alone contained 474 capacitors and 385 resistors. Crystal oscillators had to maintain frequency stability while the tank beneath them shook itself apart, firing its main gun. Motorola's Chicago factory became an assembly line for the invisible weapon. Production numbers tell the story. 1943, 3,800 units. 1944, 11,400 units. 1945, 24,000 units. Total, more than 50,000 radio sets. Every single Sherman tank, all 49,324 manufactured during the war, received a complete radio system. 100% deployment. No other nation came close. The German handicap. Understanding American superiority requires understanding German poverty. Heinz Guderian built his reputation as the architect of Blitzkrieg on one fundamental insight: armored warfare requires communication. His 1937 book Achtung, Panzer treated radio equipment as essential as ammunition. Guderian's early victories in Poland and France proved his doctrine correct. Rapid advances depended on commanders coordinating movement through radio networks. But Guderian's doctrine died in German factories. In 1943, German production lines manufactured approximately 5,700 medium tanks. They produced fewer than 2,000 Fu-G5 radio transceivers. Simple arithmetic revealed the crisis. Only 1 in 3 German tanks could receive a radio. and many of those radios went to command vehicles and assault guns rather than frontline combat tanks. The standard German tank platoon of 5 vehicles told the story. Perhaps 1 or 2 carried FUG-5 transceivers capable of both transmitting and receiving. The others mounted FUG-2 receivers. They could hear orders but couldn't respond, couldn't report enemy positions, couldn't call for help. German tank crews fought wars of enforced silence. When command tanks died, easily identified by their multiple antennas, entire platoons lost the ability to coordinate. They continued fighting as individuals, blind to each other's struggles. Technology gap. The technical differences between American and German systems seem modest on paper. In combat, they proved unbridgeable. American SCR-508, frequency modulation, FM, 25-watt transmitter operating range, 20.0 to 27.9 MHz. Crystal-controlled frequency stability, plus or minus 0.01%. Dual receivers allowing simultaneous monitoring of multiple channels. Range, 7 miles while moving, 10 to 15 miles stationary. Integrated BC606 intercom system, dynamotor power supply with filtered stable output. German FUG 5: amplitude modulation, AM, 10-watt transmitter. Operating range, 27.0 to 33.3 MHz. Variable capacitor tuning, plus or minus 1% drift. Single receiver range, 0.5 to 1 mile while moving, 2 to 3 miles stationary. Limited or no intercom capability. Power drawn directly from vehicle electrical system. The fundamental difference lay in modulation technology. Edwin Armstrong's FM system, licensed to the US military, eliminated the static that made AM systems nearly useless in combat conditions. Every spark plug firing, every track grinding against stone, every electrical motor generated interference that German AM radios translated into noise. American FM radios delivered clear voices even as artillery shook the earth. German FUG-5 radios used variable capacitors for tuning. The devices drifted constantly, forcing operators to readjust frequencies during combat. American crystal oscillators maintained rock-solid stability. Tanks preset their channels before battle and stayed locked to those frequencies regardless of vibration or temperature changes. The dual receiver configuration gave American commanders superhuman awareness. They monitored their immediate platoon frequency while simultaneously hearing company-level command nets. Orders flowed down instantly. Situation reports flowed up without delay. German commanders heard one frequency at a time, forced to choose between tactical and operational awareness. Tunisia, the first revelation. When Operation Torch brought American armor to North Africa on November 8, 1942, the Afrika Korps represented Germany's most experienced armored force. Veterans of desert warfare, they understood tank combat better than green American crews. But the Americans possessed an advantage German veterans had never encountered. The Battle of Kasserine Pass, February 14 to 24, 1943, ended as a German tactical victory. Rommel's forces inflicted heavy casualties and pushed American units back. German after-action reports celebrated the triumph. Then German intelligence officers read the intercepts. Scattered elements of the U.S. 1st Armored Division had maintained coordination across 50 miles of broken terrain. Tank crews who had never met coordinated attacks. Units called artillery support from batteries they couldn't see. The transmissions arrived crystal clear at ranges where German radios produced nothing but static. More troubling, every American tank transmitted. Not just command vehicles, every single tank possessed full communication capability. One German signals intelligence report from the 10th Panzer Division noted, "American units maintain communication at ranges that render our equipment ineffective. Every vehicle appears to function as a command vehicle. The implications are unclear but concerning. The implications would become devastatingly clear." Italy, 1943. American armor arrived in Italy in September 1943, facing terrain that should have neutralized radio advantages. Mountains blocked signals. Valleys created multipath interference. Visual communication became impossible. German commanders expected American coordination to collapse. Instead, FM technology revealed another advantage over AM systems. Frequency modulation handled the complex signal reflections of mountainous terrain far better than amplitude modulation. Where German radios failed completely, American radios maintained contact. During the advance toward Cassino, First Armored Division tanks separated by ridgelines coordinated attacks with precision German doctrine claimed required visual contact. After-action reports described routine coordination at distances where German equipment was useless. German forces found themselves fighting an enemy that operated beyond the laws of physics as Wehrmacht training manuals understood them. The bocage problem, Normandy, 1944. Sherman tanks rolled off landing craft at Normandy on June 6, 1944, their SCR 508 radios maintaining contact with naval fire support, a level of joint coordination German technology couldn't approach. But the hedgerow fighting exposed an American vulnerability. Tank radios operated on 20.0 to 27.9 MHz. Infantry radios, SCR 300, operated on 40.0 to 48.0 MHz. The frequencies were incompatible. In the bocage, ancient farming hedgerows that created a maze of natural fortifications, German infantry armed with Panzerfaust anti-tank weapons could stalk American tanks, while nearby American infantry had no way to warn the tank crews. American innovation closed the gap within weeks. Tank crews welded ammunition boxes to their vehicles' exteriors and mounted EE-8 field telephones inside, wired directly to internal communication systems. Infantry could pick up the phone and talk directly to tank commanders. By Operation Cobra in late July, this crude modification had revolutionized combined arms warfare. Operation Cobra, Total Dominance, July 25 to 30, 1944. Major General Edward H. Brooks commanded the 2nd Armored Division through Operation Cobra using radio networks that turned over 200 Sherman tanks into a single thinking weapon system. German defenders from Panzer Lehr Division, once Germany's elite armored formation, faced capabilities that seemed impossible. American tanks responded instantly to threats reported by units miles away. Artillery strikes arrived within minutes of target identification. Scattered formations coordinated complex maneuvers through terrain where visual contact was impossible. Every tank knew every other tank's position. The contrast with German capabilities was absolute. Panzer Lehr's tanks operated mostly without radios, depending on visual signals in terrain where visibility rarely exceeded 100 meters. The few functioning FUG-5 radios suffered from interference and range limitations that prevented effective coordination. Heinz Guderian, the man who built German armored doctrine on radio communication, watched his own principles destroy his forces. By 1944, serving as Inspector General of Armored Troops, Guderian recognized the disaster, but couldn't fix it. A December 1944 memorandum acknowledged that American communication superiority negated German advantages in tank quality. Germany had invented radio-coordinated armored warfare. America had perfected it. The student had surpassed the teacher. The psychology of isolation. Numbers and technical specifications miss something essential: the human experience of tank combat. American crews fought connected. Even when physically isolated, separated by miles of hostile terrain, they remained psychologically present to each other through radio waves. They heard friendly voices. They knew help existed seconds away, that artillery support could arrive within minutes, that other crews knew their position and would respond if they went silent. German tank crews fought alone. Unable to communicate with adjacent vehicles, they experienced profound isolation, even when physically close to friendly forces. They saw threats but couldn't warn others. They took hits but couldn't call for help. They died without anyone knowing. Otto Carius, one of Germany's most successful tank commanders, wrote about communication challenges in his memoir Tigers in the Mud, though he focused more on tactical implications than the psychological weight of isolation. The silence between his words speaks volumes. Industrial mathematics. Motorola's Chicago factory represented American industrial mobilization at its peak. Before the war, they made civilian car radios. Converting to military production required complete retooling. Each SCR 508 radio demanded precision assembly of 2,748 individual components. The BC604 transmitter contained 474 capacitors and 385 resistors that had to meet exacting standards. Crystal oscillators required manufacturing tolerances that pushed American industry's capabilities. They made it work. The production numbers tell a story of industrial dominance. Radio production. American. 50,000 plus complete radio systems. German. approximately 6,000 Fu-G5 transceivers. Tank production, American Sherman, 49,324 vehicles. German medium-heavy tanks, approximately 12,000 vehicles. Deployment rate, American radio deployment, 100% German transceiver deployment, 20% communication. Effectiveness, American fire mission time, 3 to 5 minutes. German fire mission time, 15 to 30 minutes. America didn't just outproduce Germany. They equipped every single tank with technology most German tanks never carried. The Soviet comparison. Soviet tank forces suffered even worse communication poverty than Germans. The T-34, the most produced Allied tank of the war, typically entered combat without any radio equipment. Soviet doctrine relied on flag signals and pre-battle planning. Against German forces in 1941, this created catastrophic coordination failures. Lend-Lease provided some relief by 1943. American radios, including SCR-508 sets, equipped some Soviet command tanks. But even at war's end, only about 25% of Soviet tanks carried radios. The comparison illuminates American achievement. While the Soviet Union struggled to equip 1/4 of their tanks with any radio, America achieved universal deployment of sophisticated FM systems more advanced than anything else in service. Aracourt. Numbers don't lie. September 1944. The 4th Armored Division encountered multiple German panzer brigades near Aracourt equipped with Panther tanks. On paper, the Germans held every advantage. Panther tanks mounted superior armor and the high-velocity 75mm KWK-42 gun that could destroy Shermans at ranges where Sherman guns couldn't penetrate Panther armor. German crews possessed more combat experience. German engineering was objectively better. Radio coordination proved decisive anyway. Every Sherman reported enemy positions instantly through clear FM transmissions. Tank destroyers received targeting information from tanks miles away that couldn't directly see the targets. Artillery observers in Sherman command tanks called devastating barrages within minutes of enemy contact. Over 3 weeks of combat, the 4th Armored destroyed 281 German armored vehicles. They lost 41 Shermans. 7 Germans died for every American. The kill ratio defied every technical specification. Superior armor and firepower lost to superior coordination. Intelligence failure. German intelligence never understood what defeated them. Combat reports mentioned American coordination, but attributed it to superior training and communication discipline rather than technology. A captured September 1944 intelligence assessment stated, American tank units demonstrate good radio discipline and coordination. This appears to result from extensive training and rigid communication procedures. The assessment completely missed the technological foundation. German tactics never adapted because German leadership never grasped the gap. They continued targeting supposed American command tanks based on antenna configurations, not realizing every Sherman could coordinate responses. They planned ambushes assuming American formations would lose cohesion when separated, not understanding that radio contact maintained coordination regardless of visual contact. The failure represents one of World War II's great intelligence disasters. Despite hundreds of battlefield encounters demonstrating American communication advantages, German leadership never prioritized solving the communication crisis in their own forces. Remagen, speed of command. March 1945. The 9th Armored Division discovered the Ludendorff Bridge at Remagen still standing, a miracle that offered the first Rhine crossing into Germany's heartland. Radio reports reached 1st Army headquarters within minutes. Within an hour, divisions across the entire front began shifting to exploit the opportunity. American forces demonstrated command and control speed that German forces, dependent on telephone lines American aircraft had systematically destroyed, couldn't match. American radio coordination created an impenetrable bridgehead defense. Tank platoons from different battalions integrated seamlessly through compatible radio networks. German counterattacks, poorly coordinated due to communication failures, arrived piecemeal and were destroyed individually. Communication collapse. April 1945. The encirclement of the Ruhr pocket demonstrated the culmination of American communication superiority. American armored columns from the 1st and 9th Armies coordinated a complex double envelopment entirely through radio communications. Inside the pocket, 325,000 German troops found themselves trapped partly because their own communications had collapsed. American fighter bombers, guided by radio-equipped forward air controllers, systematically destroyed German communication nodes. Wehrmacht units lost contact with higher headquarters and adjacent units. Field Marshal Walter Model's final transmissions before communication failure captured the German experience. No contact with adjacent units. No communication with higher headquarters. Fighting continues, but coordination impossible. German forces fought blind, while American forces operated with perfect awareness. Post-war verdict. After Germany's surrender, American technical intelligence teams systematically evaluated captured German equipment. U.S. Army Technical Intelligence Report No. 176 delivered the verdict. German tank communications equipment lagged approximately 5 years behind American systems. The absence of frequency modulation, limited radio distribution, and poor electrical suppression created critical vulnerabilities that German forces never overcame. Soviet evaluators reached identical conclusions. Given access to both German and American equipment, the Red Army chose to copy American radio designs for post-war development rather than German systems. Legacy: the network defeats the platform. The principles established by Sherman tank radio superiority govern modern armored warfare. The German Bundeswehr, rebuilt in the 1950s, prioritized communications based on World War II lessons. Every Leopard tank manufactured carries comprehensive radio systems. Bundeswehr training manuals explicitly state, "The defeat of superior German tanks by inferior American vehicles with superior radios teaches that information dominance outweighs platform superiority." Modern conflicts validate this lesson repeatedly. During the 1991 Gulf War, coalition forces with superior communications destroyed Iraqi forces equipped with individually superior Soviet-designed tanks but inferior radios. In 2003, American forces again proved that network-centric warfare defeats platform-centric warfare. The revolution historians associate with 21st-century military transformation actually began in 1942, when the first Sherman tank with an SCR-508 radio entered combat. From that moment, the fundamental nature of warfare changed. The side with superior communications defeats the side with superior weapons. The network defeats the platform. The connected overcome the isolated, the invisible victor. Field Marshal Wilhelm Keitel allegedly remarked at Germany's surrender, "We knew how to build better tanks, but you knew how to make them work together." Whether the quote is accurate or apocryphal, it captures essential truth. America built 49,324 Sherman tanks, but more importantly, America built 49,324 nodes in history's first battlefield network. Each tank carried not just a 75mm gun and sloped armor, but 181 pounds of radio equipment that created collective intelligence no individual German tank could match regardless of armor thickness or gun caliber. German forces discovered this reality through bitter experience across 3 continents, from Tunisia's deserts to Italy's mountains to France's hedgerows to Germany's final battlefields. They witnessed American coordination that defied Wehrmacht doctrine about what tanks could achieve without visual contact. They never developed effective countermeasures because they never fully understood the technological gap. German commanders saw American tactical superiority but attributed it to training and numbers rather than recognizing the electromagnetic revolution occurring in frequencies they couldn't hear. By the time German leadership understood that every Sherman possessed communication capabilities most German tanks lacked, the war was decided. In the end, electromagnetic waves proved more powerful than armor-piercing rounds. The ability to coordinate, to share information instantly, to fight as unified formations rather than isolated individuals. This invisible advantage determined victory more surely than any visible superiority in armor or armament. The Sherman tank's radio superiority established the fundamental principle of modern combat. Connection equals survival, isolation equals death. German troops learned this lesson too late, discovering on battlefields from Kasserine Pass to the Ruhr Pocket that Americans possessed not just numerical superiority, but technological superiority in the dimension that mattered most: the ability to transform individual tanks into a single thinking weapon. The war was won in whispers carried on radio waves that German crews never heard until silence claimed them forever.